Everyone, I welcome you to another episode of Global Education Zone Mathematics for Senior Secondary School 1. And in this particular episode, we are going to be talking about modular arithmetic. So now, modular arithmetic is all about the calculation and looking for values in modulos. Now, these modulos, they are just like your bases. Just like your base 1, base 2, base 3, base 4. Now, we have modulo 1, modulo 2, modulo 3, modulo 4. So now, this modular arithmetic, you do them just like your circular arithmetic. Now, for example, if you eat rice every 4 days, now just saying, now that is, if you are going to look for the day you eat rice next in terms of the days of the week, then you make use of your mode 4. So that's a modulo 4. So you can just call it a circle. It's like a circular event. So you eat rice, assuming you eat rice on Sunday, then you eat rice the next 4 days. So you have to eat rice so it's like a circle. So if you eat rice on Sunday, you have to count the next 4 days. That's Sunday, from Sunday, Monday, Tuesday, Wednesday, Thursday. So the next day you eat rice is Thursday. Then the next day you eat rice is after Thursday, the next 4 days is Friday, Saturday, Sunday, Monday. So the next day you eat rice is Monday. And then after Monday, the next 4 days is Tuesday, Wednesday, Thursday, Friday. That's Friday. So the next day you eat rice is Friday. So and then you can just draw a virtual circle, and this is how modular arithmetic works. So depending on which mode you are working with, now here we are working with 4 intervals, so we have 4 nodes in our circle. So assuming we are working with 5 intervals, so assuming you eat rice 5 each every 5 days, so that would be modulo 5. That's we will have 5 nodes on our circle. So that's just an example of how modular arithmetic works. So let's try if we can talk about one of that. Let me change from talking about events to numbers. So for example, if we have numbers as modular arithmetic, so you know that the base 4 has 3 digits, has 4 absolute values: 0, 1, 2, 3. Now if we start from 0 and we counted 4 places, that would be 1, 2, 3, 4. We'll go back to 0. If we counted 4 places again, we'll go back to 0, 1, 2, 3, 4. Now what I'm trying to say is that anytime you move the base number of times, or the modulo number of times from a start point, you get back to that point. So for example, we are in modulo 4. So if we move 4 times away from a point, we will get back to that point. So from 0, if we move 4 times, 1, 2, 3, 4, we'll still get back to 0. From 3, if we move 4 places, 1, 2, 3, 4, we'll get back to 3. So that is an example. This is a simplification. This is how we can understand and break down modular arithmetic. So an application of this fact is whenever you are given complex numbers to simplify, you can always break them down in terms of their multiples, and then you write the remainder as the value. So for example, if we are looking for what's the value of 5 places, when we move 5 places on this circle, so where will we get from? Starting from 0. If we start from 0 and we move 5 places, we'll move 1, 2, 3, 4, 5. So that means 5 equals, we'll land at 1. That would be 1 mode 4. And this mode 4 is the number of nodes on our circle. So we have 4 nodes, 1, 2, 3, 4. So that would be our mode, or our modulo. Now this is simply how modular arithmetic works. So for example, if we are looking for the value of 2, if we move 2 plus 9 places on the circle, so that's a total of 11 places. And if we moved 11 places, you can be counting, or you can just use the multiplication method. So multiplication method simply means you divide this division method, not multiplication method. You simply divide 11 by 4, which is the modulo, and then you write down the remainder. So when you divide 11 by 4, it will go twice. So 4 in 11 is 8. Then you have a remainder of 3. So that's 3 will be the value. That's 3 mode 4. So now I hope you understand the concept, the simple concept. Let's move on to expand and extrapolate more examples from this. Now let me go on to another example. Let's reduce 55 to its simplest form in modulo 3 and modulo 5. Now we're looking for the simplest form of 55 in modulo 3 and modulo 5. So basically what this will mean is 55 in modulo 3 will be 55 divided by 3, and we'll write the remainder modulo 3. 55 divided by 55 divided by 5, we'll write the remainder modulo 5. Now 55 divided by 3 is it goes in 5 one time, remains 2. 3 goes in 25 8 times, remains 1. So that will be 1. The remainder of 1 modulo mod mode 3. Then for the value of 55 in mode 5, you divide 55 by 5, that will be 11. So if 11 remains as 0, so that's your remainder, which is 0, will be your value, 0 mode 5. So this is simply how modular arithmetic works. And now this 0 mode 5, you can still replace it with circles of the same mode. For example, this 0, if we add 5, that will be 5. 0 plus 5 is 5. That will still be the same thing. 0 mode 5 is the same thing as 5 mode 5. Because when you divide 5 by 5, you have a remainder of 0. You still get back to 0. Now, for example, if what I'm saying is that if we are dealing with mode 4, and when we move 4 places, we'll still get back to our initial value. So moving, when you add or subtract this, when you add or subtract the modular value from a number, you won't get a different answer. You will still get an equivalent answer. So modular arithmetic works a little bit tricky, but it has a little bit of let's say shortcuts and loops that make us jump some steps. So now let's move on to performing the 4 basic arithmetic processes: addition, subtraction, multiplication, and division. So we are going to be performing these 4 basic processes using modular arithmetic. So let's see how it goes. So addition, let's try adding first. So for addition, it involves a very simple process. So we are looking for 8 plus 6 mode 5. So we are looking for the value of, what's the value of 8 plus 6? 8 plus 6 in the mode of 5. 8 plus 6 modulo 5. Or you can just write it in full. You can write it in abbreviation, in short form MOD, or you can write it in full MODULO modulo 5. Either way is acceptable in mathematics. Now we are looking for the value of 8 plus 6 modulo 5. So this plus, you might often see it enclosed in a circle. The plus sign can be enclosed in a circle to differentiate it from arithmetic addition. So this is modular addition, not arithmetic addition, but they work in slightly different ways, but they are fundamentally the same. Now the first thing we are going to be doing is we are going to be adding these numbers. So we are looking for 8 plus 6 mode 5. So first of all, let's look for the addition. So when you add 8 plus 6, that's 14 mode 5. Now in modular arithmetic, whenever you have such a number that is greater than the mode, you cut it down. So you divide that number by the mode, and you divide, and then you write your remainder. So when we're looking for what's the value of 14 mode 5, we divide 14 by the mode, which is 5. So 14 divided by 5, that's 14 goes in 2 places and remains 4. Now our 4 will be our value, and then we'll see write mode 5. So 14 mode 5 is still the same thing as 4 mode 5. That is an example of how you answer this question. And even if you keep adding 5, if you keep adding that modulo, you will still get the same equivalent answer. For example, 4 plus 5 will be 9. It's still the same thing as 4 mode 5. 4 mode 5 is 9 mode 5. 9 mode 5 is 14 mode 5. So that is how it works. That is addition. And no matter what question you are given, you can still use the same basic steps and simplify it down to its roots. Now let's go on to how do you perform the process of subtraction. So subtraction works very simple, just like addition, but this time around, when you get your negative answer, you add instead of subtracting or dividing, you add your modular. For example, if we are looking for the value of let's say 1 minus 2 mode 4. What is 1 minus 2 mode 4? Now 1 minus 2 gives a negative number, that's minus 1 mode 4. Now this time around, we are going to be adding 4. The reason being that when we add the modulo, which is 4, it won't alter our answer. It will give us an equivalent answer. That means this minus 1 mode 4 will be still the same thing as minus 1 plus 4 mode 4. Then finally we have 3 mode 4. So that means 1 minus 2 mode 4 is 3 mode 4. Now you can, if you still have if you go back to that part of the video where I drew a circle, you can see that when you minus 2 places from 1, when you go 1 backwards, you will get to the position 3. So that is still the effective value in the mode of 4. Now let's go on to multiplication. How do you multiply? So multiplication is just like addition, in that you just get your answer and then you divide by 4, or you subtract 4 successively till you get the lowest possible answer. So for example, what is the value of 3 times 2 mode 4? So 3 times 2, let's enclose the multiplication symbol in circle. 3 times 2 mode 4. That was 3 times 2 is 6 mode 4. Let's not forget to include the modulo in brackets. Now let's subtract 4 from 6. That's 2 mod 4. So 6 mod 4 is still the same thing. It's equivalent with the 3 equals to sign, equivalent to 2 mod 4. That's how multiplication works. You still break it down to your basic form in the modulo. Now lastly, let's talk about division. Division operation in modular arithmetic. So for example, assuming we're dividing 2 by 3 in mode let's say in mode 5. So okay, let's use mode 4. So 2 divided by 3 mode 4. 2 divided by 3 mode 4. So first of all, we divide 2 by 3, but this time around we can't just write our decimal answer. So let's say 2 divided by 3 equals x. Let's call it x. So then when we cross multiply, we have 2 equals 3x mod 4. Now in this division of modular arithmetic, we'll make it of a way we can add a number to that to our answer, so that it will be divisible by the variable. So for example, if 2 equals 3x mod 4, so let's say what can we add to 2 to make it divisible by 3x? Let's add 4, which is the mode. We'll simply be adding multiples of 4. So 2 plus 4, that's 6, is equals to 3 mod 3x. So let's divide both sides by 3. That gives x equals 2. That's 2 mod 4. So this is how modular arithmetic works. So thank you for watching till the end of this video, and see you next episode.